In a previous video, I talked about how Unix operating systems are fundamentally insecure and how I solve many of these problems in my Serenum operating system. On the Serenum Discord, we had some confusions and questions regarding how this is achieved, and so today I'm going to walk through some more of the details on the mechanisms that make Unix insecure, but mostly about how Serenum solves these issues by turning file systems and really file system APIs on their head. So let's start with the Unix example. On Unix, because the purpose of Unix was time sharing of many users on one system, the primary security mechanism is the user, right? So here we have the user is Bob. Now Bob accesses his email. Bob accesses his email through the email program, which runs as Bob. Right? So when the email program wants to open a file, the system checks, can Bob open this file? Okay, great. Then let this IO operation occur. So Bob uses his email program, and then this is simplified, but say the emails get saved in emails.txt, which is a file on the system. Next, Bob goes to play he goes to play some craft mine with his friends. And this is all fine, craft mine has to load textures off the disk, etc. And so, when it tries to load stone.png, a texture, it checks, can Bob read this file? Yes, indeed, Bob is allowed to read stone.png because it's his file, he created it, everything is fine. Everything is fine until CraftMine has a vulnerability, okay? And when CraftMine has a vulnerability, because it's a multiplayer game, it connects to the internet, CraftMine could be convinced by a malicious attacker to access other files on the system. In this case, emails.txt. And when CraftMine, but again, as far as the system is concerned, this is Bob that's doing this. When Bob opens the file emails.txt, of course he's allowed to do that because it's Bob's file. And you can see here the fundamental problem where we don't distinguish between programs. All the programs that Bob runs get treated as an extension of Bob. There's no discrimination based on what the purpose of the program is or what it's trying to do, what it needs to have access to. It just gets access to everything under the Bob user. Now, in this situation, what might happen is, CraftMine encrypts emails.txt, and then Bob is told, hey, you have to pay this guy on the internet some ransom amount to get your files back. Certainly there could be worse outcomes, but that's, a typical bad outcome. In order to go through how Serenum handles this differently, or where this isn't an issue that can even occur on Serenum, we need to go through some basics. Okay, so let's say we have a different game called Data Donkey 3 in this case. Well, if it wants to access, Data Donkey 3, we presuppose that Data Donkey 3 has access to a file handle for the example directory I have here. Well, the way things work on Serenum is that we then use this file handle to derive new file handles. These file handles are local to the process. So here this is file handle 34, and then we use this to derive handles for example directory player.png, level 1, etc. Now, these are actually read-only handles. Now, what happens if Data Donkey wants to modify the level file? Let's say I built an in-game level editor that could be, something useful. Well, in this case, actually, if I want to be able to modify the file, we have to go back to that initial file handle and change it for a mutable file, or in this case, a mutable directory handle. And then with this mutable directory handle, we can derive mutable file handles from it. And so now we can edit the level1.txt file perfectly fine. The kernel's view of the process, of the data donkey process, is this, where there's a table and then we keep track of 4 categories of things: the immutable directory handles, the mutable directory handles, the immutable files, or file handles, and the mutable file handles. And this is has been a source of confusion for some people I've explained this to. These file handles, they are numbers, yes, but the numbers are local to any one process, as in when you perform a syscall to, say, read a file, you provide a file handle. The kernel then is looking up that file handle in your process local table, in this table, say, in front of us here, and says, okay, so you want to write to this file. Well, which file is that? You gave me file 35, then it goes and tries to find that and says, yes, here is file 35. That is a mutable handle, so we can allow this to happen. But if it's an immutable file, if it's an immutable handle, then the operation will fail because you can't do that. And then, of course, if you just made up some handle that doesn't actually correspond to anything in this table, then that's also going to fail. Well, because the kernel simply doesn't know what you are talking about. It doesn't understand you. And so we can imagine, if we start a process by default, all these process tables are empty. There's no content to all these tables. And so a process can access no files by default. It can only access files it was given handles to, or handles it's derived from its already existing handles. So just to go through again, we say we have this handle 489, we perform a syscall, and then we get more handles out. This could be like, well, the syscall would just be, what are the files in this directory? You give it one handle, that's the directory you're talking about, and then you get back an array of new handles representing the files in that directory. So this is not going to be clear, but I have to read it anyway. In the beginning, there were program arguments, and the program arguments had with them the file handles, and the program arguments were the file handles, and without handles were not performed any I/O operations that were performed. Now, in other words, this is just restating what I just said, in that when we start up, by default, the process or the program doesn't have any file handles, so it cannot do anything. It's the common source of this, of handles that we get in the beginning, are the program arguments. Because, of course, on Serenum, program arguments aren't strings like on Unix. You can have a string argument, but arguments are often file handles, in that you'll say here, invoke in the shell, editor.pb, and then we use this M notation to say, hey, this is a mutable handle to mypoem.txt I want to give. Now, the shell is doing the heavy work here of interpreting the text we type in and deciding what that means. And then it is going, when it asks the kernel to start up editor.pb as a program, it says, yes, and I would like it to start with these program arguments. And in this case, it would just be one argument, a mutable file handle. Now, this gets, more elaborate. Say if we want to have, many editors want to have config files, perhaps mini config files. Well, what we could do then is we could say, hey, I'm going to run the editor, and I'm going to pass a mutable directory for the config directory, a mutable handle to the config directory, and then a mutable handle to whatever file I'm editing. This would allow, you could imagine, if you were being particularly autistic about it, maybe you only allow, you give an immutable handle to the config, because the editor shouldn't be allowed to edit its own config or something. I think that's a bit silly. Most programs want a good user interface for a program has, edit and then preferences, so you can edit things or change things about the program and then have that be persistent across runs. And so then this is what that would enable. We would have a mutable, the program arguments would be a mutable directory handle and then a mutable file handle. And then from these two handles, the program would derive all the other handles it used. In this case, it's probably just going to be that second argument and then some config files from the first. This is quite cumbersome to write, though. It's pretty long. So what we can do is we can shorten this with a shell alias, where we say, hey, when I say edit, what I really mean is run this editor binary with mutable access to this config directory that's over here in the corner. And then, of course, this just brings us down to, edit this file, edit that file, edit this file. Very easy. We've gotten back to the sort of Unix comfort and ease and usability, but we have this whole other layer of security, because of course this editor program can still only access its configuration files and this poem.txt file. But what if we want to run things in a window manager? Here is a screenshot from the window manager I'm working on for Serum. We have this run menu. What then? We cannot pass command line arguments when we run something from a run menu. Or maybe we could, but it'd be super annoying that we don't want to do that most of the time. But we can actually copy from our alias example that, hey, we already had to do an install step to register this program as a graphical program with the window manager. So the window manager could just take care of, passing these config directories to programs. And then, perhaps that would be our full solution. So what we would do is we would say, hey, the window manager is going to have some directory over here called the window manager data. In there, we're going to have the executables that you can run from the run menu. Then we are going to have this configs directory. And inside there, we're going to have configs for our programs. For example, here, datadonkey3 might have save games and stuff that are persistent across runs of the game. The editor might have a keybinds file, etc. This could be anything you want, but basically, as a graphical program, you are guaranteed to have this this directory to put stuff in across runs of your program. Excuse me. I should have gotten some water before recording this. Yeah, and so the mutable data flows when we run the DD3 binary. It gets access to this other directory with the same name. And we know there are no name conflicts because it's an explicit install step to register these new programs with the window manager. So we can just enforce that there are no, we can enforce that there are no naming conflicts. Technically, Serum does actually support, because we do everything through file handles, Serum can handle, there are two files with the exact same name in a directory. That's actually fine because Serum, the kernel, doesn't care. Many of the Serum programs don't handle that very well right now, but that's something to fix. Anyway, what was I going to say? Oh yeah, the great thing about this is when you, so first of all, when it's run by the window manager like this, the config is, of course, the global config that you have for the game. But say I'm a developer for Datadonkey 3. Well, instead of actually needing to implement in Datadonkey a switch to say where to look for the save games, so that my developer version of the game doesn't corrupt my actual save files that I have. And so I don't need to back stuff up. In this case, when I run the developer version of DataDonkey from the command line, I would pass in manually this config directory myself. And what's so great about that is it makes things way more deterministic and reproducible. If a customer of the game has a problem, well, they can just zip up this DD3 folder and the binary and send that to me, and then I can guarantee that on my Serenum system, it will run the exact same and have the exact same bugs. So you get perfect reproducibility from this thing where we've minimized the amount of mutable state or configuration state that could be causing all kinds of weird issues. We've localized that all to one place, and so we get exceptional reliability and reproducibility from this design. Now, the second thing as well is that here we actually know which programs have configuration and which don't. And I think it's actually quite a true pattern that mostly command line programs should not have configuration. Like, you'd be really, really upset if GCC looked in, like, can you imagine if and it wouldn't surprise me if they added this because it's that crazy, but can you imagine if GCC had, it looked in /etc/gcc.conf to check if it should enable SSE2 or something. Or, you have a project and you send it to your friend, and then he can't compile it because something with his compiler is different, was configured differently from yours. Oh yeah, except this is super common, maybe less with specifically GCC, but all the time it's very hard to build a programming project because something compiling is dependent on an entire system configuration of system libraries and headers and include paths and all this craziness. We eliminate all of that, and we don't eliminate it by developers volunteering to help. We've eliminated it by enforcement, and so this is going to be effective. Anyway, there's a final case we haven't covered, which is open file menus. Because I could sense that some of you were thinking that already, that I haven't mentioned that. The way an open file menu works here is, say we have the ghastly image manipulation program is running under our window manager. Instead of the ghastly image manipulation program having access to your entire file system and being able to ruin it, and then also having to implement its own ghastly file opener dialog box, we simplify things tremendously by just having the ghastly image manipulation program call into the window manager through the same mechanism it uses to, open a new window or whatever. This communication already exists. So we have this call that goes one way. Now the window manager, that's a trusted process, can open us a graphical, file picker menu where we select the files we want the ghastly image manipulation program to be able to look at. We can select, hey, is this read only, or is it, write access or mutable? We can do all this. Then the window manager gets, opens, it goes and gets this file, it has a file handle, then it sends it to the ghastly image manipulation program. And then notice here that when it goes across this boundary, it gets a new number because the previous file handle is in the space of the window manager, and then the new one is in the space of the ghastly image manipulation program. And so we have the one advantage of security here. We also have the advantage of always native file menus. So I think if you're on an Apple platform, for example, you won't pass, I suspect you won't pass QA testing unless the thing that your program opens is the sanctioned official SDK file opener menu, because they want you to use that. Here we don't need to worry about that. We actually make it easy for developers to make something that feels native, because native is the only option. The ghastly image manipulation program can only ask the window manager to open a native dialog box. What this means as well, for the Linux cells who like their customizability, is there's no messing around with themes and crazy configuration state, because your window manager can open whatever open file menu that you want, which means you can make it as mouse driven as you want, as keyboard driven as you want. You can mess with the colors, you can make it like a 3D experience, you could do anything. And you have that control because we've correctly and clearly divided the responsibility and given that to the window manager. I think that was all I wanted to say today. You can read more about Serenum or join the Discord at samhsmith.com/Serenum. You can also buy a Serenum today at taberna.shop. I will see you in the next video.